Good afternoon, guys. So my learning target for you today is to graph an equation using an input-output table. Specifically, that's using a chart, okay? We're getting into graphing lines, linear equations. But one thing I noticed with some of my kids today, or actually a lot of my kids today, is we have trouble with graphing points. So a really quick review on graphing points, all right? I want you to picture the coordinate plane as a skyscraper building. All right, now the green line here represents the grass. So this brown is underground. And we got the blue sky and clouds and so forth, okay? When you build a skyscraper, you do not just build a metal box on top of the ground. To make it more stable, you build several floors under the ground. And so here, when I teach kids how to plot points, I don't know, a number of teachers teach it a lot of different ways. And I'm going to teach it this way. So the first number is the x value and the second number is the y value. And you need to know that, okay? The horizontal axis is the x-axis and the vertical axis is the y-axis, okay? That's important. But a lot of times students reverse these two numbers and graph them opposite, or they're just a lot of different things. So I'm going to try to give you one more strategy for graphing if you need it, okay? So I want you to imagine this is a building, and the front door is the origin right here. When you walk into a skyscraper, you walk in the doors, and there's usually a bunch of elevators. So X is going to represent your elevators, and Y is going to represent the floor that you're going to go to. Okay? And when the floors are negative, that means these basement floors that are located under the ground for stability purposes. And positive would be numbers above the ground. So if I was graphing 2, -4, that means I go in the door to the building, I go over to the second elevator, and I go down 4 floors. Okay, and the capital letter is just a name tag. Just put a capital A next to that dot to say which dot, what it is, the name. 0, -3. So 0 is the elevator number. So if I walk in the door, that's the first elevator I see. I'm not moving to elevator -1 or elevator +1. I'm walking straight in to the 0 elevator. And I'm going down to the 3rd floor. And that's B. C says 1, 0. So I'm going in the door, I'm going to elevator number 1, but I'm staying on the ground floor. So I'm just going to the elevator, I'm not getting in it and going anywhere, and that's point C. And if I wanted to, I could connect those dots and make a triangle. So you're going to hear me trying to help you graph points by using the elevator example. Okay? Okay. So what I did in class is we started out with an equation. All right. Now you're used to x + 2 equaling 7. And then I could subtract 2 both sides and I could get x is 5 and I'm done. Okay. Well, let's say I don't know the number 7. And instead of a 7, it's going to be a y. As a matter of fact, instead of the equals y being at the end, it's going to be in the beginning. Y equals x + 2. Okay? That's what the equations are going to look like. Now, because I have 2 variables, I have many, many, many possible values for x. In fact, x can be any number I want. If I wanted x to be 5, I could. And then 5 + 2 would be 7. I could have x be -8. -8 + 2 would be -6. X could be 100. Okay? 100 + 2 would be 102. I don't really want equal signs here. X could be a decimal. 4.5. 4.5 plus 2 would be 6.5. Okay, now in class I kind of made a joke today. Okay, we got a good list started. Now everybody make a list of all the possible values for X and Y. That would, if I add 2, that would work. Okay, and some people started writing lists. But a few of you looked at me like I had 3 heads because, gosh, the number system goes on and on forever. And that's just whole numbers. Okay, what if I put a 3 here? That would give me a whole new set of points. What if I put a 7 here? Okay, so when you factor in how many numbers there are, you know, the positive numbers go up to infinity, negative numbers go to negative infinity, and everything between 2 whole numbers, between 4 and 5, is a decimal with any number of decimal places. There's basically infinitely many number combinations. There's no way we could list all the number combinations that would, when I add 2 to it, make the Y value. So, if you've ever heard the phrase, a picture is worth 1,000 words, in math, we do it better. We make a picture that's worth an infinite number of solutions. Okay? So what we're going to do is make a picture of all the possible combinations of X and Y that will work in this equation. So first we start off, we make this thing called an input-output table. And what that does is X's are inputs and Y's are outputs. Alright, and those are the most important 2 columns. And the middle column is where we're going to get all the work, do all of our work. So on the previous screen, I showed you that we can make X literally anything we want. But looking at the graph, I wouldn't want to make X 100. Because this graph stops, this is a 6 here, technically that's a 7. Our graph doesn't go past 7. So making any number in this column greater than 7 would be pretty useless. Okay? So I'm going to pick small numbers that fit on the graph, and I'm going to pick small numbers that I can do in my head easily, although you're welcome to use a calculator. So for example, 0, 1, and 2 are easy choices. 0, 1, and 2 are easy choices. Alright, so 0 plus 2 would be 2. 1 plus 2 would be 3, and 2 plus 2 would be 4. Okay, so for the purposes of graphing, now we got to take this data and graph it. So I'm covering up that middle column because it's a distraction. It's not information we need for graphing. What the inputs represent now are our elevators, and our outputs represent the floors that we're going to go to. So 0, 2 would mean I'm going in, getting on the 0 elevator, and riding it up to the 2nd floor. 1, 3, I'm going in the building, I'm going to elevator number 1, riding it up to the 3rd floor. I'm going in the building, 2nd elevator, up to the 4th floor. Now, those 3 dots give us the beginnings of a line. Okay, I will know if I did this right if I have 3 dots in a row. If one of the dots is out of place, I will know that I did something wrong. That's why we use 3. 2 dots, you might not catch a mistake, but 3 dots you will. Okay, if they're not 3 dots in a row, I have to check all 3 rows because that doesn't tell me which one that it is. So I've got 3 dots. Now, because I teach algebra, I always think ahead. And when you take algebra next year, you're going to do equations or graphs that are much more complex. So for reasons that I'm not going to get into right now, I just want to tell you that what I want you to do is once you see the pattern these 3 dots are following, I want you to plot more dots that would fall within the same line. So the pattern I see is to get from this dot to this dot, I went up 1 and over 1, up 1 and over 1. So I'm going to keep doing that. until I get as far as I can. And I'm going to go in both directions, following that same pattern. Okay? Now we have some dots. But remember how I said decimals were involved? So for example, if I went to 1.5, 3.5 would be my y value. In fact, halfway between here, and then halfway between these points, and then halfway between throughout. As I draw more dots in between them to represent all the fractions and decimals that it can be, you can see that the dots connect to form a line. So I'm just going to connect these with a line to show that between each dot, the values, the decimal values in between, all are represented. Lastly, we talked about how our values go from positive infinity to negative infinity. So I need to put arrows at the end of the line to show that even though I ran out of room on my graph, because we can only draw a graph so big, the actual values that will work in this equation go on and on forever. Okay, and then this is really, really, really important, but easy to forget. Label the line with the equation. And you're also going to be asked on your homework if a given value is a solution. A solution would mean that if I continued the chart and I used 10 for an x value and subbed it in, would I get 12? Well, 10 plus 2 does equal 12. So we would say that 10, 12 is a solution. And I want you to write that sentence. It is literally the point and 3 words. You can do it. Okay? All right, let's move on to the next one. Move that black box for a second. All right, here again, I'm going to actually skip around a little bit. I'm going to go to the one that has a negative sign in it, negative 2x plus 1. Here again, we're using 0, 1, and 2. We're going to pick easy numbers. The title of that middle column is just the expression part, negative 2x plus 1. Okay? And remember, negative 2 next to the x means multiply, so we're going to sub in these 3 numbers for the x. So negative 2 times 0 plus 1, negative 2 times 1 plus 1, and negative 2 times 2 plus 1. Okay, a lot of you are used to the dots. I really want to make you more comfortable using the parentheses because that's what you'll see more of. Okay, so 0 plus 1 is 1. Negative 2 plus 1 is negative 1. And negative 4 plus 1 is negative 3. I would really recommend that, especially if you're involved in negatives and you're not good at negatives, that you type it in and get the right answers. Okay, I am not judging you on how well you do arithmetic. I want you to I want you to graph the points correctly and know how to get them. Okay, so here again, we are ignoring this middle column. My box went away. There we go. We're ignoring that middle column, and we are going to the 0 elevator to the first floor and putting a dot. We are going to the 1 elevator down to the negative first floor and putting a dot. We are going to the 2 elevator and going to the negative 3 floor and putting a dot. And I know that I'm doing this right because the 3 dots are in a straight line. They follow an over 1 and down 2 pattern. Okay, so I'm going to continue that pattern in both directions. So if I went up, I would be going up 2 over 1. So continue that pattern. Once I have my dots, connect. Okay, some of you are going to be better at straight lines than me, I hope. You can use a ruler or just any straight edge, maybe a piece of paper you have nearby or the edge of a book. Make sure you put arrows on the ends and make sure you label y equals negative 2x plus 1. Okay. Then there are some that have fractions in it. In a fraction 1, choose, you could start with 0, but don't do 0, 1, and 2. Count by the denominator. So I'm going to count by 2's. Why? Because counting by 2's makes it so that you don't end up with fractional answers over here. 1/2 x minus 2. So half of 0 is 0. Take away 2 is negative 2. Half of 2 is 1. Sorry. Half of 2 is 1. 1 take away 2 is negative 1. Half of 4 is 2. 2 take away 2 is 0. And I'm not going to do the graphing and stuff like that because you can see how to do that. That's not any different. I want to make sure I address the fractions. Alright, on the homework one, there's a homework one I want to do. Number 6. The fraction is 2/3. So I'm going to count by 3's. Again, the purpose of that is so that when I multiply by 2/3, I don't get fractions. I would highly encourage you, if you're not good at multiplying by fractions, to use your ABC button. 2 ABC 3 times 3 plus 2, and you'll get 4. 2 ABC 3 times 6 plus 2 equals 6. Okay, so I hope that helps with the fractions. All right, the rest of the problems work the same way, the rest of the parts of the problem. And see you next time. Have a good day.